Okay, so before we kickstart with today's lesson, I will spend a quick 5 minutes. Okay, I'll spend a very quick 5 minutes to do a very quick recap, to do a quick summary with you all on what we have learned in the last lesson. So last week we started with the first lesson of your Form 5 chemistry. So we are starting with the first chapter of Form 5 chemistry called Redox. Okay, Redox. Okay, so this one, okay, this is actually a very long chapter, a very long chapter. Like what I say, we'll probably use 3 to 4 months just on this chapter alone. 3 to 4 months just on this chapter alone. Yeah. So first of all, we learn what is redox. Redox means there is reduction and also oxidation. These two processes. Yeah. So redox means reduction and oxidation occur at the same time. Okay. So if the chemical reaction only have oxidation or only have reduction, that is not a redox. Okay, you must have both. Number two, we learned that there are total 4 methods to help us to decide whether the process is oxidation or reduction. So we can use oxygen method, oxidation number method, hydrogen method, and electron method. So I mentioned in last lesson how to memorize this by looking at the first letter. If the first letter is the same, put a plus. If the first letter here is different, put a minus. Okay, so plus means gain. So if you gain oxygen, if the oxygen getting more and more is oxidation. If the oxygen getting lesser and lesser is reduction. Yeah, and so on. So I told you these 4 methods. The oxygen method is very easy. Hydrogen method is very easy. Oxidation method and electron method is hard. Okay. So last lesson, we already completed oxygen method. We already completed hydrogen method. And we are actually halfway of oxidation number. So we started with oxidation number method, but not complete yet. So today, we will finish off the oxidation number method and electron method. And today, we will do a lot of questions together. We will do a lot of questions to really improve your understanding. Okay? I will also do a lot of state papers with you today. A lot of state papers with you all today so that you know how to apply. So today's lesson is going to be very technical. Today's lesson is going to be very, very technical. Just follow me. So if you have anything not sure, please ask. Okay. So like what I say, disclaimer. For those of you who didn't attend last week's lesson, you probably will feel very lost for today, but you will be fine. Okay. So what you need to do is that just follow us as much as you can today and watch the recording for last week's lesson. Okay. As soon as possible. Yeah. All right. So let's start. Okay. So I want to do a revision a little bit on oxidation number also. So oxidation number, let's do a quick revision. Okay, oxidation number revision here. Okay, there are 4 rules to determine the oxidation number. There are 4 rules to help us to find out the oxidation number. So if let's say we have element means anything made by only one species. Anything that got only one species, they are element. So element, the oxidation number is always 0. Number 2, if we have ion, the oxidation number is always same as the charge. Example, aluminium is Al3+, the oxidation number is positive 3. Okay, zinc is Zn2+, oxidation number is -2. Okay, Cl minus chloride ion, oxidation number -1. So if you know the charge of the substance, the oxidation number just copy back the charge. That's it. Number 3, oxidation number for oxygen is always -2. So when you have oxygen, the oxidation number is always -2, except 2 special cases. Number 1 is O2. So O2 is oxygen gas. So oxygen gas only has one species, only O, nothing else. So when you only have one species, you are element. So element, the oxidation number is 0. Follow back rule number 1. Okay, oxidation number of element is 0. Okay. So another one is H2O2. H2O2 is called hydrogen peroxide. So H2O2 is just like a water. Water have only one O. So you add another one O, H2O2. So this substance called hydrogen peroxide. So hydrogen peroxide also got oxygen, but this oxygen is not -2. It is -1. Other than that, oxygen always -2. Example, magnesium oxide, the oxygen is -2. Aluminium oxide, the oxygen is -2. Carbon dioxide, the oxygen is -2. So oxygen is always -2 except these two special cases. Next one. Oxidation number for hydrogen. Hydrogen is always +1 for the oxidation number. Okay. So example, water inside got hydrogen, so it's +1. Sulfuric acid got hydrogen inside, so it's +1. Hydrochloric acid got hydrogen inside, so it's +1. So it's always +1, except two special cases as well. One is hydrogen gas. Hydrogen gas only have H, nothing else. So when you have only one species, is element. So element, the oxidation number is 0. So we learned this last week. So another one is called metal hydride. What is metal hydride? When you have metal combines with hydrogen, like metal, sodium combined with hydrogen. So this is metal hydride. Metal, magnesium combined with hydrogen. So when metal and hydrogen combine, you have metal hydride. Metal hydride, the hydrogen inside here is not +1, but it's -1. So these special cases you must know. Okay. So all these things is what we learned last lesson. Okay. So we also covered two examples in last lesson. Yeah. Right. That's it. Right. So up to this moment, is everyone okay? Can everyone still remember or recall back what we have learned last week? Is everyone okay so far? Okay. Right. Good. So now, okay. So what we going to do today is we're going to do some very special case in a short while. Okay, let me use another one more example to demonstrate. So we have example 1, example 2. So let's do a very quick self-test. Let's do a self-test. I want you all to participate. I want you try to do it. Okay. Then if everything is okay, then only I teach you something new today. Okay, so let's do it. Okay, self-test. Okay. So let's say you are given something like this. You are given something like this. Okay. So let's say we have aluminium plus oxygen to become aluminium oxide. Okay. So let's do this together. So first and foremost, before you do anything, it's very important to make sure the chemical equation is balanced. So let's balance the chemical equation first. So I do it quickly. So that's it. So this chemical equation is balanced. Okay, so now I want to use oxidation number method. So we have 4 methods. So we want to focus on oxidation number method for now. So I want to use oxidation number method to check who undergo oxidation and who undergo reduction. Okay, so let's look at it. So if you want to use oxidation number method, first and foremost, you need to list out all the oxidation number. So let us list out the oxidation number, and I need your participation. I need everyone to participate. Okay, I hope you guys not only keep quiet and do nothing, because if you only keep quiet, I have no idea whether you understand or not. So I hope you guys can participate as much as possible. So let's try it. Okay, so tell me in the chat box, what is the oxidation number for aluminium here? What is the oxidation number for aluminium, everyone? Let me read through your answer. Okay, all right, so far I can see 0. Very good, it's 0. Okay, why? Because the aluminium here only one species, only Al, nothing else. So when you only have one species, it's element. So when it's element, the oxidation number is supposed to be 0. Next one, oxygen gas. Anyone can tell me what is the oxidation number for oxygen gas here? Okay, good. Okay, well done, well done. Still 0, because the oxygen gas O2, you only have O, nothing else, only have one species. So when you only have one species, you are element. Element, the oxidation number is 0. Okay, settle. Okay, good. Tell me the oxidation number for the aluminium over here. What is the oxidation number for this aluminium? Okay, all right, very good. +3 because we know the charge of aluminium, right? Aluminium, the charge should be Al 3+. So when you know the charge of somebody, the oxidation number just copy back the charge. So +3. Very good. So what is the oxidation number for the oxygen here? Okay, very good. Awesome. -2, because according to rule number 3, oxidation number for oxygen should be always -2. And it's true because we know the charge of oxygen is what? O2 minus. So it's true. So the oxygen should be -2. That's all. Okay. So after you list out all the oxidation number, then what we do? So last week we learned something called apple to apple comparison. Last week we learned about apple to apple comparison. You must compare the right one. Always choose one apple on the left and one apple on the right to compare. You cannot compare left and left. You cannot compare right and right. Must be left compared to right. Okay. So I choose aluminium as one of the apple, compare with this aluminium. So from the left to the right, this aluminium oxidation number is 0. This aluminium oxidation number is +3. So I can see that the oxidation number increases. So when oxidation number increases, the process is oxidation process. So this fellow aluminium. So aluminium undergo oxidation. Okay. Or you can say aluminium is oxidized. So when aluminium undergo oxidation, what happened? So remember I mentioned last lesson. Okay, I mentioned last lesson. All right. So the substance who undergo oxidation, what you are? Reducing agent, because whatever process that happen to you, you will be the opposite agent. So if you undergo oxidation process, you will be reducing agent. So the aluminium is the reducing agent. That's it. Okay. So I see in the chat box, okay, all right. Srinivas, you are typing the answer, which is very good, but you make a mistake, huh? Okay, so Srinivas actually get a very good answer, but what is the mistake he made? All right, anyone can point out what is the mistake that he made? Anyone? Okay, very good. You shouldn't put the 4 in front, huh? Or the number in front here only for balancing purpose. This number only to balance. So when you want to write who undergo oxidation, who is reducing agent, don't include the number 4 here. This number only used to balance equation. Yeah, right? So that's it. Okay. So it's good. Okay, right. Great. You are good. You are good. Okay. I'm very glad that you typed the answer. Very good. Okay. We are here to learn together. So don't be afraid of making mistakes. Now, when you type the answer, at least I can point out your mistake and together we learn it and together we can avoid the mistakes, which is good. Right. Next one. Let's choose another apple comparison. Oxygen is another apple compared to this oxygen. So let's compare. Always remember, compare left to right. You cannot do right to left. Sequence is important. Always left to the right. Okay, on the left-hand side, the oxygen is 0. On the right-hand side, oxygen, the oxidation number is -2. 0, -2. The oxidation number decreases. In exam, can you write the word ON? Cannot. You must spell the full name, oxidation number. You must spell out the full name, oxidation number. So oxidation number decreases. So when oxidation number decreases, what is the process? Reduction. So who undergo reduction? This fella. So this fella, the 3 in front, don't include, is for balancing. So this fella, O2. So O2 undergo reduction. So you can say O2 is reduced, or you can say O2 undergo reduction. So both answer acceptable. Just 2 different ways to write it, but it's both acceptable. When O2 undergo reduction, you will become the opposite agent. So remember, you always be the opposite agent of the process that you undergo. So if you undergo reduction, you are oxidizing agent. So O2 is oxidizing agent. Okay, so that's it. So this is everything that we need to know. Okay, nothing new. We haven't learned anything new yet. Okay, everything that we learn, okay, everything that we learn is some things that we covered in the last lesson. All the things that you have seen here is something that you learned in the last lesson. Nothing new. Okay. So finish. All right. Okay, all done. Huh? Okay, so now, so hopefully this one gives you a very good idea what we learned. Huh? Because this is very important. And for today's lesson, we will do a lot of cases like this. Okay, now, okay. So the next thing is very important. Okay, so remember last week we learned what? 4 rules, right? Okay, so the 4 rules that we learned, okay, can be used, okay, can be used to determine or to predict, okay, the oxidation number for probably about 90% of substances. Okay, I would say most of the chemical substances, the oxidation number we can use the 4 rules to find out. Okay, but where is another 10%? Okay, where is another 10%? Okay, all right. So Haida, how to use oxidation number method for compounds. Don't worry, I'll teach you in a short while. I'll teach you in a short while later. Okay, all right. So now, so this one is only 90%. So where is another 10%? So sometimes there are some oxidation number that is cannot be predicted. Okay, sometimes, okay, there are some oxidation or some unknown. Okay, sometimes we have some unknown oxidation numbers, okay, that cannot be predicted. Okay, what do I mean? What do I mean by unknown oxidation number that cannot be predicted? Okay, let's say, right. Let's say we have aluminum oxide. We know aluminum is Al3 plus, so plus 3. We know oxygen is always -2, right? But what if we have carbon dioxide? Do you learn about the charge of carbon before? Yes or no? Do you guys learn about charge of carbon? Yes or no? No, all right. If you say yes, something wrong, okay. You never and you shouldn't learn about the charge of carbon before for your Form 4 or even Form 5. No, we never learn the charge for carbon. So that's it. So then we don't know the charge of carbon. So we don't know the oxidation number of carbon. Or let's say, all of a sudden they give you something, okay, W2O3, 2 minus. They ask you the oxidation number of W. So for us, what the heck? Who is W? I not even know who is W. How on earth I can know the oxidation number of W? Okay, you get it? So I want you all to understand the 4 rules that we learn is very, very useful. But sometimes there are some oxidation number, the 4 rules also cannot do anything about it. Okay, so what should we do? Okay, so what should we do? Okay, so here you should use a method. Okay, so I'll teach you how to calculate the unknown oxidation number. Okay, I'll teach you the method how to calculate the unknown oxidation number method. Okay, I'll use probably 4 to 5 examples to let you see the idea. Okay, then if you still don't understand what it is, you let me know. Okay, so how to calculate the unknown oxidation numbers? So this is the strategy. Okay, so number 1, let the unknown oxidation number. So the oxidation number that you don't know, let it to be X. Can you use W, Y, Z? Also can. You can use any unknown. Any unknown, you can put it up to you. Okay, I love to put X lah. Okay, number 2. Then you need to sum. Sum means total. Sum out all the oxidation number. I want you to total up all the oxidation number in the whole compound. In the whole compound, you have many, many oxidation number. I want you to total up together. Don't worry, I will use example to do demonstration. I'll make sure you know how to do it. Number 3, then you equal the total oxidation number to the charge of the compound equal the total oxidation number to the charge of that particular compound. Okay, how you know the total charge of the compound? You refer to the top right corner. Always look at the top right corner. Why? Because if there is any charge, the charge always put on the top right corner, right? Al3 plus. You see the charge on the top right corner here. Okay. Let's say W2O3 7 minus. The charge is always on top right corner. You never put the charge at left. You never put the charge in the middle. You always put the charge on the top right corner. So if let's say in this case, the top right corner here, you see nothing, you don't see anything here, means what? The total charge is 0. That's it. Okay. So after you equal the total oxidation number to the charge, so in the end, you solve for the X. You just solve and get the X. So X is the oxidation number you want to find. Okay. Now, let us use some example. Okay, let me use some example for demonstration, because without example, you'll find it very blur. Okay, you'll find it very, very blur. No worry, I'll show you. I'll show you how to do it. Okay, so let's try. Okay. Okay, so let's try this. Okay, so let's say example number 1. Okay, I want to find the I have carbon dioxide. I want to find the oxidation number of the carbon. Okay, I want to find the oxidation number of the carbon here. So do I know the oxidation number of carbon? Don't know. So anything you don't know, let it to be X. So we have X. Okay, all right. So how many carbon here? 1 carbon, so 1X. So if here got 2 carbon, 2X. If here have 4 carbon, 4X. Okay, all right. So now, do we know the oxidation number for oxygen? Yes, oxygen, the oxidation number is how many? What is oxidation number for oxygen? Can anyone type in the chat box for me? What is the oxidation number for the oxygen? -2, not 0. Why not 0? Because you have carbon and oxygen combined together. So you have 2 species. When you have 2 species, this is not element. So when you are not element, the oxidation number cannot be 0, -2. All right, -2. So the oxygen here is -2. How many oxygen we have? 2 of it. So you must multiply by 2. Why is it? Imagine this, carbon dioxide, you have what? CO2, you have a carbon and 2 oxygen. Am I right? 1 C and 2 O. Do I know the oxidation number for carbon? Don't know. X. Do I know the oxidation number for oxygen? Yes, -2. Do I know oxidation number for this oxygen? -2. Okay, so you add everything together. So why I multiply by 2? Because I got 2 oxygen here. Every oxygen, the oxidation number is -2. So -2 times 2. So then we add everything together. So we just add everything together. Okay, so you see, let the unknown oxidation number to be X. You add all the oxidation number together in the compound. Then you equal the total oxidation number to the charge of the compound. So what is the charge of this compound? So always look at the top right corner. Sorry, I write wrongly. This is not compound. Top right corner. Top right corner. So look at the top right corner. Do you see anything here? Nothing. You don't see anything on the top right corner here, right? So equal to 0. So if here got 2 minus, so equal to -2. If on top here got plus, equal to +1. Okay, so this total oxidation number always equal to the total charge of the compound. So let's say for this one is 0. So do your mathematics, X equal to +4. That's it. So the carbon here is +4. So far so good. Okay, so that's how you do. Very easy only, very easy. But one of the common mistake for many students is what? Many students, when they do this thing, they only write X equal to 4, which is wrong. Because I mentioned in last lesson, when you come to oxidation number, you always need to show the sign, no matter it is positive or negative. So no matter it is positive or negative, you always need to show the sign. Okay, oxidation number always need to show the sign. Okay, let's go for another one more example. Okay, let's go for another one more example. Okay, let me make it a little bit harder. Let's say MnO7 2 minus. Okay, MnO7 2 minus. That looks complicated. I want to find the oxidation number for Mn. Okay, so how to do? Same thing. Mn. So Mn, I don't know what it is. All the oxidation number I don't know. Let it be X. So how many Mn I have? 1 Mn. So 1X only. So add with the oxygen. So oxygen, what is the oxidation number? -2. How many oxygen we have? 7 of it multiplied by 7. So you add the oxidation number Mn and also the 7 oxygen, add together, equal to what? Always equal the whole thing to the charge of the compound. So the charge of the compound can be found on the top right corner. So look at the top right corner. Put your eyes, look at top right corner. So there is a charge here, -2. So do your mathematics, X equal to, all right. Let me see. Okay. Sorry, this one should be minus. Okay. I change a bit, MnO4 minus. Okay, all right. So here, so MnO4, you have Mn, which is X, oxygen, which is -2. You have 4 oxygen times 4. So everything add together equal to the charge. The charge is here negative. If you don't see number, -1. So do your mathematics, you will get +7. Okay, so I get a question. Okay, what if you don't put the positive sign? 0, no marks. Okay, if you don't put positive sign, everything is wrong. Everything is wrong. Although number 7 is correct, everything is wrong. So that's why, remember, when it comes to oxidation number, you always need to put a sign, no matter it's positive or negative. Okay, guys, let me know in the chat box. If, for example, 1 and 2, 1 and 2. All right, is it okay for you? Can Okay, some people will say, sir, if I don't want to use the X, can or cannot? You can do at this. Okay, MnO4 minus. Can you do this? Do you know oxidation number for Mn? You don't know. Copy back Mn. So add with oxygen. Oxygen, do you know? -2. How many oxygen? 4 times 4. Equal to the total charge, -1. So in the end, Mn equal to +7. Also can, no problem. Okay? You have the choice. Do you want to let this thing you don't know to be X, or you want to copy back the symbol that you don't know? Also can, no problem. Just like this question, carbon dioxide, I don't know the carbon, I can copy back the carbon. I don't want to use the X, also can. Oxygen is -2, I have 2 oxygen. Everything total up together equal to the total charge. So top right corner, you don't see anything, 0. So carbon is +4. Any method also can, as long as you understand and you know how to use it. That's it. So there's no best method in the world. The best method is the method that you understand. Yeah, all right, simple as that. Okay, so now let me try another, maybe 2 more example with you. Oh, maybe I show you another 2 more example here. Right, this is example 1, example 2. Okay, let's go for another one more. Okay, another one. Okay, example number 3. Okay, what if I make the whole thing looks a little bit more different? Okay, let's say I have a substance called W. I have a W, I have 2 of it. Then I have chlorine. And then chlorine, I have chlorine, I have how many? Okay, I have 3 chlorine. Okay, and then this whole thing to become a positive. Okay, so same thing. I want to find the oxidation number for W here. Same thing lah. You can use the X or just use W will do lah. Let's say I just copy back the W. I don't know W. How many W I have? 2 W. So put 2 here. Okay, because why you put 2 in front here? W2Cl3 means what? You have W, W, Cl, Cl, and Cl. You have 2 W. So when you do calculation, you always put the 2 in front here, just like when you do mathematics, 2x plus 3y, right? You never write x2 plus y3, right? When you do mathematics, isn't it? Okay, so that's why you have to be careful. Okay, so you have 2w here, and then add with chlorine. Do you know oxidation number for chlorine? Anyone can type in the chat box, let me know. What is oxidation number for chlorine? All right, very good. -1, because we know Cl minus. That's why it's very important for you to know the charge. You learn all these charge in your Form 4 Chapter 3. If you don't know the charge, so you are in trouble. So you really need to catch up the charge as soon as possible. Okay, I have seen somebody like 2 weeks before SPM, aluminum Al2 plus. Cannot okay, like magnesium Mg4 plus. Okay, 2 weeks before SPM, you are in big trouble. So you really need to know the right charge for the substance. Okay, that's it. So chlorine, it's -1. We have 3 chlorine times 3. So all the things add together, okay, equivalent to the total charge of the compound, +1. Okay, so do your mathematics here. So you get, okay, do it quickly W equal to +2. Okay, so that's it. All right. So not very hard. Okay, is it possible they only ask you 2 species like C and O, Ma and O, W and Cl? Can they ask you more than 2 species? Yes, they can ask you more than 2 species, and nothing to worry because the concept still the same. Example, let me show you this. Okay, let me show you another one. Let's say we go for a very famous one, sulfuric acid. Sulfuric acid, what is the formula, everyone? H2SO4. So let's say I want to find the oxidation number for the sulfur in the sulfuric acid. So same thing. Do you know oxidation number for hydrogen? Yes. According to rule number 4 that we learned previously, hydrogen always +1, isn't it? Hydrogen always +1. How many hydrogen we have? 2 hydrogen multiplied by 2. Do we know oxidation number for sulfur? Don't know. So you can let the sulfur here to be X, or you can copy the symbol S. Up to you. So add with oxygen. Oxygen is always -2. How many oxygen we have out there? 4 multiplied by 4. So equal to what? So add everything together equal to the total charge. So total charge, put your eyes on the top right corner. Top right corner, you don't see anything. So 0. So the sulfur here is +6. Okay, so everyone, I need your feedback. I need you to let me know in the chat box. How's everything? Okay, so it's not very hard. Okay, so it's combine all the knowledge we learn together. So it has to start with 4 rules, because if you don't understand 4 rules, if you don't understand the 4 rules that we learned last week, then you cannot do this. Okay, so you have to combine the 4 rules and also the X method. Okay, 2 things combined together, then it is possible to do it. Okay, so now let me show you some real examination question, and the question that came out in the real exam. How they ask? Very straightforward. The way they ask the question, very straightforward only. Yeah. So let's look at this. Okay. So let's go for this one first. Okay. Yeah. So let's start with this question. Okay. This is a SBP question. SBP question. All right. In year 2022. This is one of the trial exam paper. So you're given 2 compounds, okay, zinc chloride and iron oxide. So they ask you what is the oxidation number for zinc and iron. So for zinc, do we need to calculate the zinc? No need, because we know the charge for zinc, right? Zn2 plus. When you know the charge, you will know oxidation number same as the charge, +2. So it must be C or D. That's it. So iron, we need to calculate. Why? Because we know iron can be Fe2 plus or Fe3 plus. So Fe can be 2 plus or 3 plus. So I don't know it's 2 plus or 3 plus. So anything you don't know, you have to do your calculation. So Fe2O3. So Fe you don't know, copy back, or you want to write X also can. How many Fe? 2 Fe. Add with 3 oxygen. Oxygen is what? -2. So add together equal to what? Total charge of the compound, Fe2O3. Do you see total charge on the top right corner here? Nothing, 0. So do your mathematics, the Fe here is positive 3. So the answer is donkey. So can you please let me know in the chat box, are you okay with how I do the question for this? Quite easy, okay? This question quite simple, isn't it? This is exactly the same question they asked you in the trial exam paper. Not very hard. So you don't think all the question in the trial exam paper must be hard one. No. Some of the question can be this easy. Okay? Some of the question can really be that easy like this. Yeah. So that's all. Okay? If you really understand the concept, it's okay. So next one. Now, this question, they ask you what is the oxidation number for manganese. Manganese is Mn in these 3 substances. So these 3 substances, all of them got Mn. So you want to find the oxidation number for Mn for all of them. Okay? You want to get the oxidation number for Mn for all of them. So let's try it. So KMnO4. K is what? K plus. Oxidation number +1. Mn, don't know. Copy back. Oxygen is -2 times 4. So equal to total charge. Do you have total charge here? 0. So Mn is +7. So the Mn here is +7. So let's do the same thing. K2MnO4. K2MnO4. Same thing. The K here is what? K plus. So K plus is what? +1. How many? 2 of it times 2. Mn, don't know. You can put Mn or you can put X, up to you. Oxygen is 4. Every oxygen you know is -2 equal to 0. So do your mathematics. Mn equal to +6. Yeah. Okay. So 7 and 6. So 7, 6. So 7, 6. So these 2 is wrong already. So last one, MnO2. So this Mn, I don't know, copy back, or you want to put X also can. Oxygen is -2. How many oxygen you have? 2 of it times 2. Add together. Everything add together must equal to the charge. Put your eyes on the top right corner. You don't see any charge, 0. So Mn equal to +4. So +4. So the best answer is B. Okay? I hope you guys can see how it works. It's not hard at all. In fact, it's quite easy. So now I don't want to keep giving you the input, because if I keep giving input, I'm the one who know how to do, but you are the one who go for exam. You are the one who sit for the paper. So I want you to try. Can I give you 1 minute? You try to do this question for me. Find the oxidation number for chromium, the Cr for me, and type the answer in the chat box. Can you try to do it for me? Take your time, try to do it, and then type in the answer in the chat box. Yeah. If you don't know how to do, type a cross if you really don't know how to do. Yeah. Okay, very good. Well done. So far, I only see one answer given in the chat box, which is C. No other answer. So anyone don't know how to do this? Anyone? If you don't know how to do, can you type an X for me? Anyone? Okay. So I assume everyone know how to do. Yes, the answer is C. Very good. Fantastic. Very, very good. Okay, that's it. So now, okay, next one. Okay, so how Okay, let's do another one more page together here. Then only we come back and do something else. Okay, here. All right, this one. Okay. So here got 3 questions. Look, here got 3 questions. Can I give you 2 to 3 minutes, maybe 3 minutes, 1 minute each, for you to try to do the question? So once you're done, type the answer in the chat box. You can put comma, for example, the first answer, let's say A, second answer B, third answer C, A, comma, B, comma, C, A, C, comma, A, comma, donkey, like this, okay? Try to do it. I give you 3 minutes. Yeah, you can try to do it now. Okay, so far, based on the answer that I can see in the chat box, the answer you guys write is D, right? D, A, and C, which is correct. Okay. So for those who don't know how to do the question, let me demonstrate it. Let me solve it in 1 minute. K2Cr2O7, we want to know the Cr. So the potassium is K plus, so the oxidation number is +1. You have 2 of it times 2. Chromium, you don't know, you can let it to be Cr or you can let it be X, up to you. How many chromium out there? 2 chromium. So oxygen, you know, is -2. Oxygen, you have 7 pieces of it. 7. Okay. So all the oxidation number add together equal to the charge of the compound. So the charge of the compound is on the top right corner. So on the top right corner, I don't see anything up there. 0. So do your calculation. The chromium is +6. That's it. So X2O3, 2 minus. So I want to find the oxidation number for the X. So X, I don't know, just let it be X. I have 2X times 2 in front. So add with oxygen. Oxygen is -2. I have 3 oxygen out there. So the total oxidation number for this whole compound is equivalent to the total charge. The total charge is on the top right corner here, which is -2. So do your mathematics, you get +2. That's it. Lastly, this question is SPM 2007, a very old question, but still very relevant. What is oxidation number for oxygen in O2? You not even need to calculate. O2 only have O, 1 species. Anything have 1 species called element, and we learned before element, the oxidation number is supposed to be 0. That's it. So not even need a calculation at all. So you not even need to X out whatever thing, no need to use the X method. It's very straightforward. Okay, so guys, well done. I can see that you guys can really get the idea. You know what is happening, which is great, which is awesome. Okay, very good. Okay, very good. So this one, okay, all these questions also very easy. Okay, so okay, I just want to discuss something like that. Okay, so sometimes they can change a little bit the way they ask the question. Sometimes they can change a little bit like this. MRSM 0947. Which of the underlying elements has the highest oxidation number? So basically, it's the same thing. You still need to do your calculation. Okay, you just want to find the highest oxidation number. So you see, this question not hard, but got a bit tricky. Okay, let me show you the first one. K2Cr2O7, same thing. K is +1, you have 2 of it. Chromium, don't know, you have 2 of it. Oxygen is -2, you have 7 of it. Add together equal to total charge 0. So the chromium is +6. Okay, now the tricky part is the next one. Fe2SO4 3. Now this question is a little bit tricky. Why? Do you know the oxidation number of iron? We don't know. That's what we want to calculate. But for sure, you know iron must be Fe2 plus or Fe3 plus. Are only 2 possibilities, nothing else. So I don't know. Let Fe here, or you can put X. You have 2 iron. Now the question is what? Do you know oxidation number for sulfur? Don't know, right? Do you know oxidation number for sulfur? No, we don't know the oxidation number for sulfur. So we have problem now. We don't know the iron and we don't know the sulfur. How to do? Although we don't know oxidation number of sulfur, but never mind, we know SO4, the whole thing is what? If you remember, SO4, this whole thing got charged 2 minus, right? SO4 2 minus cause sulfate ion. This is something you learn back in your form 4. Okay, SO4, the whole thing is 2 minus. So this 2 minus is not belong to sulfur, not belong to oxygen, but the whole thing. This 2 minus is not only for the sulfur, it's not only for oxygen, it's the whole thing. So this SO4, the whole thing is -2. And then you have 3 SO4. Remember, SO4, the whole thing got 3. So SO4 is -2. You have 3 of it times 3. So equivalent to what? So you add all the oxidation number together equal to the total charge. So top right corner here, you don't see anything here, 0. So do your mathematics, the iron here is +3. So allow me to ask all of you a question. Are you guys okay with how I do the SO4, the whole thing, which is 2 minus? Are you okay with this? Because many students cannot do. They say, sir, I don't know the sulfur. I know the oxygen, but I don't know the sulfur. Okay? I don't know the sulfur. Okay? So that's the thing, right? Okay. So I think, okay, which Nash? Okay, sorry. Which Wash is it? Which Wash? Which Wash? Do you know the SO4, the charge is 2 minus? Do you know this? Do you know SO4, the charge is 2 minus? Yes, okay, now I ask you, Fe2 SO4 3. So if let's say you use the X method, do you know the iron? Don't know ma, X, you have 2 of it. Do you know the sulfur? You also don't know, right? There's no way you can have 2 unknown, right? If this one you don't know, this one you don't know, you cannot solve the question. So what should we do? FeSO4 3 means what? You have 1 Fe, so you have 2 Fe combined with 3 SO4, 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 SO4. So the Fe we don't know. You have 2 of it. SO4, what is the charge for the whole thing? Okay, which Nash? Which Wash? Can you tell me what is the charge for the SO4? 2 minus, so you have 1, 2, 3 SO4. So -2, you have 3 of it times 3. Are you okay with this? Okay, so you add everything together. So after you add everything together, you must equal to how many? 0, Okay, that's it. So solve it, Okay, settle. All right. So that's how it works. So same thing, this one easy, like PbCl4. Pb add with Cl is -1 times 4 equal to 0 plus 4. So this one I do it quickly, +1. So who has the highest oxidation number? This one. Okay, so it's the same thing, but they just ask in a slightly different way. They just use different way to ask. So they ask you who has the highest oxidation number. Okay, you still need to calculate all of them. That's all. Okay, all right. Not very, very hard. Okay, as long as you understand the concept there. All right, that's it. So all these remaining questions, I'll keep it empty for you to try it, okay, on your own. Okay, probably you can do it as your homework. You can try it on your own. Okay, finish. So now the last thing that I will teach you before I jump to the electron method, which is the last one. Okay, so now how to apply all the concepts that we have learned just now. Okay, how to apply, why we need to know all these unknown oxidation number. So let me show you using one example. Okay, let me show you using one example, and you can clearly see what is happening here. Let's say we have copper oxide, and we have ammonia, then you become copper, you become water, and you become nitrogen gas. No need to memorize. Okay, first and foremost, before you do anything, please balance it. Okay, balance the equation. Let's put a 2, let's put a 3, let's put a 3, let's put a 3. So it's balanced. Okay, so now let's say for this question, I want to use oxidation number method to find out who undergo oxidation and who undergo reduction. So let's do it. Okay, oxidation number method. Okay. Okay. So do we know oxidation number for copper? Yes, copper is Cu2 plus. So the oxidation number is supposed to be +2. Do we know oxidation number for oxygen? Yes, oxygen always -2. Okay, now come to ammonia. Remember number 2 in front, don't bother. This is only for balancing. Ammonia. Okay, my question, do we know the oxidation number for nitrogen? Do we know the oxidation number for nitrogen using the 4 rules? Yes or no? Hi guys, my question to you all. Can we find the oxidation number of nitrogen using the 4 rules that we learned? Yes or no? Okay, the answer is no, because we don't know the charge for nitrogen, right? We don't know the charge of nitrogen. So we cannot use the 4 rules. So anything that we don't know, you have to use the X method or the calculation method that we learned just now. Okay, so that's why we know when we do calculation, what we have ammonia. Do we know the nitrogen? Don't know. And hydrogen is what? +1. How many hydrogen we have? 3 of it. So add together equal to, on top here, nothing, 0. So the nitrogen is -3. So that's how we do the calculation. Okay, so from the calculation we learned just now, the nitrogen should be -3. Okay, so some people ask, sir, what about the 2 here? Should we put a 2 here? No, when you do the calculation, don't bother the 2. All the number in front here only for balance equation. We use this number only for balance the equation. Now, when you do calculation, this number in front, don't bother. Just ignore. Okay, just ignore. All right. So guys, can you let me know in the chat box, are you guys okay with how I get -3 for the nitrogen? Is it okay? So this is why we need to learn the X method just now. This is why we want to calculate, because sometimes there is some oxidation number that we cannot use the 4 rules to get it. So anything that we cannot use the 4 rules to get it, we need to do the calculation. Yeah. So everything combines together. Okay. So now next one. So on the right hand side, the copper here, what is it? This is Cu, only one species. So it's element oxidation number 0. Okay. Sorry, before that, this hydrogen. This hydrogen, how many? Hydrogen is always +1. So don't times 3. You don't need to multiply by 3. You only multiply and add everything together when you want to find something that you don't know. When you only want to do comparison, the hydrogen and hydrogen here, no need. So all the hydrogen is +1. No matter it's H3, H4, H7, whatever, all hydrogen is +1. So please be careful. Sometimes some people confuse. Okay, the times 3 here become +3. No need. Okay, you only multiply all these things when you want to find the unknown. Yeah, right. So the copper here is element, so 0. Hydrogen always +1. Okay, oxygen always -2. The nitrogen here is element, so it's 0. Okay, let me know in the chat box, do you have any doubts or any problem with this oxidation number? Anyone? Okay, because if you can list the oxidation number correctly, you shouldn't have any issue already, because the problem for many students is that they cannot get this oxidation number, or they write the wrong one. Okay, once you write the right oxidation number, the whole thing is easy. The whole thing is easy already. Okay, so now let's compare apple to apple comparison. So the first one you can see here, copper +2, copper 0. So +2 to 0, oxidation number went down. So oxidation number go down is reduction process. We learned last lesson, last week. So reduction, so it's oxidizing agent. So finish already. So next one, okay? So can we compare the oxygen here? No, this oxygen is -2. This oxygen also -2. No change. No change, don't compare. Only compare the difference one. Okay, next one. This nitrogen got -3. This nitrogen is 0. There is a change. So compare. So nitrogen from -3 to 0. -3 to 0, oxidation number shoot up. So when oxidation number increasing, the process is oxidation process. So oxidation process, reducing agent. That's all. Okay? Because we learned last lesson, Whatever process you undergo, you will become the opposite agent. That's it. Okay, finish already. So what about the hydrogen here? Hydrogen here is +1. The hydrogen here also +1. So no change. So no change. You don't need to do any comparison. That's all. Okay, finish. Okay, so that is everything that you need to know for oxidation number method. Because if you know oxidation number method, it is so powerful. Because like what I say, oxygen method you only can use when the question got oxygen. Hydrogen method you only can use if the question got hydrogen. But oxidation number method you can use in all situations. In every situation, you can use oxidation number method. That's why oxidation number method is a very, very powerful method. You can see oxidation number method is very popular method in SPM because you can use in many, many conditions. Okay, so let me spend. Okay, all right, get a question. How I know copper oxide undergo reduction? You see here. Okay, you can see the copper oxidation number is +2. The copper here is 0. +2 to 0. The oxidation number decrease, right? Use your number line. This is +2. This is 0. So oxidation number decrease. So according to the table we have, okay, when oxidation number decreases, it is a reduction process. It is a reduction process. Okay, that's it. All right. So then, Haida, you will, what about the -2? Haida, I say just now, anything no change, don't compare. Okay, you see here, the oxygen here, it's -2. Here also -2. No change, don't compare lah. Only compare the one that got changes. Only compare the one that got changes. The one no change, don't bother. Is it okay? Yeah, all right. Yeah, all right. So I hope everyone can understand this. So now we will spend another probably 5 to 10 minutes to do some other state papers. Then if everything goes well, then I will come back to teach you the last method, which is called electron method. Electron method is even more interesting, okay? But up to this moment, I hope everyone can see how the oxidation number method works. How the oxidation number method works. Okay, so now let me show you some question here. Okay, here, all right. So this one, this is a real SPM past year in the year 2022. They give you a chemical equation. They say this is a redox. So the question asks, what is the change in the oxidation number for the manganese in a chemical reaction? Manganese is the Mn here. So use whatever thing we learned today. Okay? So KMnO4, do you know the oxidation number for Mn? Don't know. You can calculate. K is K plus, so +1. Mn don't know. Oxygen is -2. You have 4 of it times 4 equal to the total charge, nothing, 0. So the Mn here is +7. So this MnCl2 is the same thing. MnCl2, Mn you don't know. Chlorine is -1 because we know Cl minus. You have 2 chlorine times 2 equal to 0. So Mn equal to +2. So easy lah. So +7 become +2. So very, very straightforward. SPM pass here. Is that easy? Yeah, is that easy? Okay, so next one. Find the oxidation number for the chromium in this entire thing. So chromium is Cr. So same thing. So quite easy. Cr2072-. Okay. So right. So why we choose the Cr here, not the Cr at here, right? So this one you will learn very, very soon. Okay. This one we will learn very, very soon. But see, they say the chromium in dichromate ion. Dichromate ion. So what is dichromate? The word di in chemistry, di stands for 2. So the Cr need to have 2 inside the ion. So you see, this Cr got 2 inside this ion. So this is called dichromate. Yeah. So that's it. So we find the Cr here. So Cr you don't know, let it be Cr. You have 2 of it, or you want to be X also can. Oxygen, you have 7 of it, which is -2, add together equal to the total charge, which is here, -2. Do your mathematics, CR equal to +6. I teach you a simple way to cheat. I teach you a simple way to cheat. Sometimes when you look at the name, like for example, sometimes you look at the name like copper 2 oxide, iron 3 chloride. Whenever you see the name got a bracket, and then got Roman number, this number is actually the oxidation number. So you see, this fella, the name is dichromate. What is it? 5 + 1, 6. So that's why the oxidation number here must be 6. Okay, that's it. So you can double check your answer. Very easy. Okay, this is a very easy one. Okay. So you cannot only write +6, cannot, because you need to show the working. Okay, the answer 1 mark, the working 1 mark. That's why the total mark is 2 marks here. All right. So I get a question in the chat box. Can we use any method, or would they state any method to use? Sometimes they will tell you which method to use. If they never mention, then you can use any method that you like. Okay. If they never tell you which method to use, you can use whatever method. But normally, they will tell you. Yeah, normally, they will tell you which method to be used. Okay, finish. All right, this one done. Okay, now let me show you another few more here. Then we go for electron method. Okay, now look at here. Now this question, which of the following equations below represent a redox reaction? Okay, again, guys. Okay. So hold on. Okay. So I want to repeat this question now that someone is asking why we choose the CR at this fella, not this fella. Okay, quite easy lah. Okay, there's a few ways. One of the simple things is this: if Cr3 plus, the name is called chromium ion. Cr3 plus. If you cannot remember, it's okay. If the Cr come with oxygen, this fella, the name is called dichromate ion. Actually, quite easy to see also. Dichromate ion means what? In this ion, in this fella, you have di. Di means 2. Chromate means chromium. So in this ion, you have 2 chromium inside. That is called dichromate. That's why I choose this ion to do the calculation and find the Cr. All right, is it okay, Jenny? Okay, can I? All right. Okay, now let's move on. Okay, now come to this question. Okay, this is a SBP trial exam paper in year 2011. So it's a little bit old, but still very relevant, still very useful until today. So let's do it. So they ask you, which of the reaction here is a redox? Okay, so this one combined something we learned in lesson number 1 and lesson number 2. Can we do a quick revision here? So first of all, everyone, think back, okay, recall back. What is redox? Redox means that you must have oxidation and reduction. You must have oxidation and reduction process. Okay. So okay. So now we have how many methods to know whether the process is oxidation or reduction? 4 methods, right? So in this question, do they tell us which method to use? No, they don't. They don't. The question never tells us which method to use. So if the question never asks us which method to use, I would strongly encourage you all to use oxidation number method. If the question never tell you which method to use, I would strongly encourage you all to use oxidation number method. Okay, because this method is the most powerful method and you can use in any situation. So can we do it together? Yes. Okay, let's look at it. Okay, what is the oxidation number for the copper over here? Copper is CO2 plus, so plus 2. What is the oxidation number for oxygen here? -2. Oxygen is always -2. What is oxidation number for hydrogen? +1. What is oxidation number for sulfur? Do we know the charge for sulfur? No, we don't know. Can we find the oxidation number for this sulfur itself? Can. So H2SO4, sulfur, you don't know, right? Hydrogen plus 1 times 2. Sulfur, don't know. Oxygen, -2 times 4. Add together equal to 0 because you don't see anything here. So the sulfur is +6. So do we know the oxidation number for the oxygen here? Yes, -2. No need to do calculation. So do we know the oxidation number for copper here? Yes, Cu2 plus, so it's +2. Do we know the oxidation number for the sulfur here? Don't know. We need to calculate. CuSO4, Cu is +2, sulfur, don't know. Oxygen is -2 times 4. Add everything together, equal to 0. The sulfur here is +6. Oxygen, how many? -2. Hydrogen, always +1. Oxygen, always -2. So I hope everyone know how I get the oxidation number here. So now let's do the apple-to-apple comparison. Copper +2, copper +2, no change, don't bother. Oxygen -2, oxygen -2, oxygen -2, no change, don't bother. Hydrogen +1, hydrogen +1, no change, don't bother. Sulfur +6, sulfur +6, no change. Oxygen -2, oxygen -2, no change. So there's no change in oxidation number at all. So when there is no change in oxidation number, tak ada oxidation, tak ada reduction. So cannot be redox lah. So number 1 is wrong. So when 1 is wrong, this is 1, this is 1. Answer A and C confirm wrong. So if you want to tembak B or donkey, yeah. So in objective, always throw away those wrong answer first. So now you not even need to do number 4. Because number 4 confirm correct already, isn't it? You only do number 2 or number 3. So let's do number 2. So number 2 here, okay? Hydrogen here, how many? Hydrogen always +1. Chlorine is always Cl minus, so -1. The zinc here is how many? 0. Why? Okay, because the zinc here only one species, so it's element. So when you are element, the oxidation number is supposed to be 0. So then, what about the zinc here? This zinc is Zn2+, so oxidation number +2. What about the chlorine here? Cl is always Cl minus, oxidation number -1. So let's compare apple to apple comparison. Hydrogen +1, hydrogen here, sorry, I didn't see here. This hydrogen, I forgot to write. This hydrogen only have H, nothing else. So it's element 0. So when you compare apple to apple, this hydrogen is +1. This hydrogen is 0. +1 to 0. Oxidation number go down. So it's reduction. Okay. So let's look at another one. The zinc. The zinc here it's 0. The zinc here is +2. 0 to +2, oxidation number shoot up. When oxidation number shoot up, oxidation. So when you have reduction and oxidation, so it's a redox. So number 2 is correct. So the answer automatic will go to B. Can you please let me know in the chat box, do you understand how I solved the question? I not even need to do 3 and 4, isn't it? I don't even need to try one by one. So that's why when you do objective, you can do elimination method. Okay, number 1 is wrong. Throw away answer A and C. Okay, so then answer B and donkey, number 4 is correct. So only check 2 or 3. That's all. Okay, so this is step by step how we do the question. Okay, not very, very hard actually. Okay, so now next one. Okay. All right, so here, okay, next one. So this one, which of the following is a redox reaction? So who is the redox here? So let's do it quickly. So same thing, okay. Copper is +2, oxygen -2. The zinc is element 0. The zinc here is the N2+, +2, oxygen -2. Copper is one species element 0. If you compare left and right, no change. Copper +2, copper, sorry, got change, sorry. The copper here +2, the copper here 0, +2 to 0. Okay, copper, the oxygen from +2 to 0. Oxidation number go down, reduction process. Okay, so the oxygen -2, -2. No change, don't compare. The zinc is 0, the zinc here is +2. So look at the zinc. The zinc is 0, become +2. So 0 to +2, oxidation number shoot up, oxidation process. Reduction, oxidation, redox. So number 1 is correct. When number 1 is correct, answer B is wrong. Okay, answer donkey is wrong. So now number 1 is here. So now we need to check the rest. Okay, so let's look at number 2. Okay, if number 2 is correct, then the answer must be C. If the number 2 is wrong, the answer has to be A. Simple as that. Yeah. So let's look at number 2. So the next one, let's have a look. The hydrogen here is what? +1, right? The Cl is Cl minus, so -1. The sodium here is Na +1. Okay. What about oxygen? Oxygen is always -2, right? Hydrogen here is +1. The sodium here Na plus, so should be +1. The chlorine here is Cl minus, so should be -1. Water, the hydrogen is +1, right? According to the 4 rule, oxygen is -2. So if you compare, what happened? Hydrogen +1 on the left, hydrogen +1 on the right, no change. Chlorine -1 on the left, -1 on the right, no change. Sodium +1 on the left, sodium +1 on the right, no change. Oxygen -2 on the left, -2 on the right, no change. Hydrogen +1 on the left, hydrogen +1 on the right, no change. So no change, no oxidation, no reduction. So number 2 is wrong. So when number 2 is wrong, the answer automatic go to A. So can you guys type in the chat box, let me know, are you okay with how I solved the question? Okay, not very hard, huh? It's definitely doable. Okay, so let me show you the last question before we move on to learn the next one. Okay, so let me see a question. What about number 3? Okay, so someone is asking me, what about number 3 here? So number 3, let's look at it. Okay, number 3, PbNO3 2 plus, okay, 2Ki become PbI2 plus 2KNO3. Now let me teach you a simple way to do this question. Okay, do we know what is the Pb here? Yes, Pb is Pb 2 plus, right? Pb is Pb 2 plus, so plus 2 lah. Do you know the nitrogen here? If you want to calculate, you can use the X method to calculate the nitrogen. If you don't want, also can. Why? You see, here the NO3, the whole thing is what? NO3, the whole thing is NO3 minus, right? This is a nitrate ion. NO3 is nitrate ion. So the whole NO3 is -1. Okay, so this whole NO3 is -1. Look at here, the right hand side. Here also got NO3, right? The whole NO3 here is what? The whole NO3 is -1. So the -1 is not the nitrogen, it's not the oxygen, but is the whole thing. Okay, let me stop here for a while. Are you guys okay with this NO3 concept? Okay, right, good. So next one, the potassium here is what? Potassium is K plus, so +1. So iodide is what? I minus. Iodide is I minus. So I minus, oxidation number is -1. Okay, so now let's look at here. This Pb is what? Pb 2 plus. Iodide, okay, the iodide here is I minus -1. Okay, iodide. So now if you compare, Pb +2 +2, no change. NO3 -1, NO3 -1, no change. Potassium +1. Potassium here, I forgot to write. The potassium here is K plus, right? +1, no change. So iodide -1, -1, no change. So no change in oxidation number at all. So no oxidation, no reduction at all. So it's not a redox. So did I answer your question, Haida? Did I answer your question? Yes, huh? Okay, good. Okay, finish. Huh? So let me do the last questions with you all before we go on to electron method. Huh? Okay, this one. All right, here. Okay. This is a SBP trial. This is a trial exam paper in year 2010. 2010 trial exam paper. So they give you this chemical equation. They ask which of the oxidation number is correct. So they are using oxidation number to do the question. So let's do it. So let us list out all the oxidation number, ON, oxidation number. Okay. What is the oxidation number for hydrogen? +1. What is oxidation number for sulfur? I don't know. Let's calculate. So H2S. When you calculate the number in front, don't bother. The number in front only for balancing equation. So hydrogen is what? +1. How many hydrogen? ×2. Sulfur? Don't know. So add everything equal to the charge, 0. So calculate. Sulfur is -2. So from here, I know sulfur is -2. That's it. So now, do the same thing for here. Nitric acid. Hydrogen, always +1. Okay, now, the nitrogen here, do I know? Okay, can we do this? Can we do NO3 here? The whole thing is -1, just like the one we have it just now. The answer is cannot. Why? Listen carefully. Because you see, just now we have this NO3 on the left and NO3 on the right. So in this case, here got NO3, here got NO3. So we don't need to find the oxidation number for N and oxygen separately. Don't need, because this is NO3, this is NO3. It's the whole thing, so they are the same. But if you look at this question, if you look at the question that we have now, this is NO3, but this is NO. They are different. So they are different. So you cannot, okay, like, oh, this whole thing NO3 is -1. Then what about this? So you only can include the whole NO3 and make the whole NO3 become -1 when left-hand side got NO3 and right-hand side got NO3. So I take a break here. Are you guys okay and understand what am I talking about? What about the rest? Are you guys okay with this? Anyone don't understand why the NO3 here? Okay, I need to find the N and O separately. But just now the question no need. Okay, I don't see anyone asking the question, so I assume you understand. So if you, let's say, you have anything not sure, please ask. Okay? If you have anything not sure, don't be shy. Just ask. Okay. So you see, when the left-hand side got NO3, right-hand side got NO3, then you don't need to find the oxidation number for N and O separately. Okay. But this is NO3, this is NO. They're different. So you need to find the oxidation number for N and also the O. So how to find the oxidation number for N? So let's do it. So HNO3, the N I don't know. So hydrogen I know, +1. Nitrogen I don't know. Copy back. Oxygen is -2 × 3. So equal to the charge, nothing here, 0. So the nitrogen here is +5. So from here, I know already the nitrogen here is +5. Oxygen is how many? -2. That's all. So the sulfur here only appear one species, is element 0. Okay, what is the oxidation number for the nitrogen here? I don't know. NO, the nitrogen, don't know. Copy back. Oxygen is -2. Add together, no charge on top, 0. So nitrogen is +2. So the nitrogen here is +2. Oxygen is always -2. That's all. So lastly, the water. So the water, the hydrogen is always +1. Oxygen is -2. That's all. So once you list out all the oxidation number, then you can do your apple to apple comparison. So let's check the answer. So the first answer say hydrogen change from -1 to +1. Hydrogen on the left, +1. Hydrogen on the right, +1. No change at all. So wrong. So oxidation number for nitrogen change from +5 to +2. Nitrogen on the left, +5. Nitrogen on the right, +2. Yes. So the answer is B. Okay, finish. So guys, please let me know in the chat box. Are you guys okay with this question so far? Okay, can right? So that's it. So I don't think it is very, very hard. I don't think it's very, very hard. Okay, as long as you follow all the rules that we learn, you are good to go. Okay, as long as you follow all the rules that we learn, we are good to go. Okay, so I think that's it. So it's not very, very complicated. Okay, so for today, so we have completed the oxidation number method so far. Okay, all right. So but there are some small details that you need to know. Okay, especially in essay. If they ask this question in essay, there are some details that you have to be very, very careful, which I will talk about it in a short while. But before I go on, okay, I don't think I want to start with electron method first today. Okay, else too many things in one day is not good. So I think today I just focus on oxidation number method will do. Okay, now I want you guys try to do this question. Try to do this question, these two. Okay, these two questions. This is a Johor paper, and this question is from Perak. So try to do these two questions and type the answer in the chat box. So you might take a little bit longer time for this question because especially this one, you have to try one by one, but just try first. Okay. So if you have the answer, please type the answer in the chat box. Like for example, the first one is A, second one is A, first one B, second one is C, for example. If let's say there's any question you don't know how to do, at least you let me know. Let's say the first question you don't know how to do, you type an X. Second question, you know how to do A. Let's say both questions also you don't know how to do, type X and X. Okay, I'll give you some time. You can try to do it now. Yeah. Okay, so I can see quite a number of answers there. Okay, so majority of you answer C and A. There are a few of you answer C and donkey. I think there are a few of you answer C and B. Okay, and some of you you know the first question but don't know the second one. But from here I can see so far from the answer I have gotten everyone know how to do the first question. Everyone answer the first question to be C. Okay, let's see what is the final answer. Let's try it. Okay, the first question is from Johor. So let's have a look how to do this question. Okay, so they say redox. So they didn't say which method to use, isn't it? They didn't say which method to use. So like what I say, if the question never specified which method to use, I will strongly encourage you all to use oxidation number method because oxidation number method is the most powerful method and you can use it for many, many situations. Okay, let's do it. So can we list out the oxidation number for the aluminium one species element, oxidation number 0. Ag plus. So when you see this fella got charge, is an ion. So when you have ion, the oxidation number copy the charge plus 1. So remember the number 3 in front, don't bother. All the number in front only for balancing purpose. So aluminium Al3 plus. So this fella got charge, so it's an ion. So when you have ion, the oxidation number copy the charge of the ion plus 3. So the last one, Ag. So Ag is one species only, so it's element. So when you have element, the oxidation number is 0. So I hope everyone know how to do it. So let's do it. Silver ion is oxidized. So silver ion is what? Ag plus, because ion means got charge. So this is the fella, Ag plus. So when you do apple to apple comparison, Ag plus and Ag, +1 to 0, oxidation number go down, reduction. So they say oxidize, wrong. So answer B, silver ion is a reducing agent. Silver ion +1 to 0, silver ion oxidation number go down, undergo reduction. When you undergo reduction, you are oxidizing agent. You always be the opposite agent. You always be the opposite agent for the process that you undergo. You undergo oxidation, you are reducing agent. You undergo reduction, you are oxidizing agent. So the answer should be oxidizing agent, but they say reducing agent. Wrong. Answer C, aluminium atom undergo oxidation. So who is aluminium atom? Atom means alone. Anything alone is atom. So who is aluminium atom? This one. Aluminium come alone. So when you do apple to apple comparison, this aluminium is 0. This aluminium is +3. So 0 and +3, oxidation number shooting up. So when oxidation number shoot up, the process is oxidation process. So yes, aluminium undergo oxidation process. So aluminium undergo oxidation process. C. Okay, so I can see so far from the answer that I have gotten, the answer that I can see in the chat box, the first one, most of you, not say most of you, all of you get it correct so far from the answer that I can see. Okay, the second one, I can see the answer, some of you write A, some of you write B, none of you write C, some of you write donkey. We try one by one. Okay, now I want to throw a few questions to you all to help you to think. Okay, this question is a very good K-BUT question. We call it K-BUT or we call it HOTS, higher order thinking skill. So this question needs some critical thinking. It's not so straightforward, but not worry, it's very easy only. So which of the following substances act as reducing agent? So as what I told you in the last lesson, so if I want this substance to be reducing agent, what process it must undergo? To be reducing agent, what process it must undergo? Anyone can type it in the chat box for me? I want to see at least 10 answers. All right, very good. Ying Chi, Jayani, Shaila, Lee, Duncan, Shinin, Haida. Very good. Oxidation, because remember, you always be the opposite agent for the process you undergo. So it's always opposite, it always terbalik. So if you are reducing agent, you must be opposite process, which is oxidation. So if you undergo reduction process, you are oxidizing agent. So this is a very important concept for all of you. Make sure everyone know. The agent and the process must be terbalik. You are oxidizing agent, so the process is reduction. If you are reducing agent, the opposite process is oxidation. Okay, so this is a very, very important thing. Okay, if you don't know this, then you feel very confusing. Okay, so any one of you still don't understand what it is. Any one of you attended last week's lesson, but still don't understand why the reducing agent must undergo oxidation. Anyone? Let me know in the chat box. If you don't know why, type me. Is it okay? If you missed out last week's lesson, it's okay. Then you watch the video first. Okay. Any one of you attended last week's lesson and don't understand this question, why I say the reducing agent must undergo oxidation process? Anyone? If you don't understand, type me. Wait for a while. Okay, so no one give me the response. I assume you all understand. So to be reducing agent, you must undergo oxidation. So very simple. You just need to check anyone which is underlined undergo oxidation process. That's all. So which method we can use? You can use oxidation number method or any method you like. For me, I love to use oxidation number method. So let's do it. Aluminium, what is the oxidation number? 0, because you are element. Do you need to do this? No need, because you only want to do the underline. Just focus on underline will do. You don't even need to bother the aluminium. Don't bother the aluminium because your focus is the underline. So the underline is oxygen O2. So this oxygen is one species, only O, right? Nothing else. So you are element. So when you are element, the oxidation number is 0. So when you do apple to apple comparison, do you need to bother the aluminium here? No need, ma. When you compare oxygen, you will compare with oxygen, isn't it? Okay. When you compare, you always compare oxygen and oxygen. Can we check the oxidation number for the oxygen here? So this oxygen, anyone can type in the chat box. What is the oxidation number for this oxygen? Anyone can type in the chat box? Okay, very good. -2. So oxygen 0 to -2. 0 to -2, oxidation number go down. Oxidation number go down. What is the process? Reduction. So when you undergo reduction, can you be reducing agent? Type yes or no in the chat box. Yes or no? No, right? When you undergo reduction, you must be opposite oxidizing agent. That's it. So I believe those of you who choose the answer A, you misunderstand really. You thought who undergo reduction. No, I want reducing agent, not reduction process. So the oxygen here undergo reduction process. So you are oxidizing agent. Answer A is wrong. Okay. So let's look at answer B. Okay. So answer B, same thing, only focus on here. Okay, N2O. So N2O, do you know the oxidation number for the N here? Don't know, ma? N2O. So N2O, the N you don't know, ma? You let it to be N. So how many nitrogen? 2 of it. Oxygen, how many? -2, equal to 0. Nitrogen is +1. So the nitrogen here is +1. Oxygen is how many? -2. So now the nitrogen is +1 on the left. Can we check the nitrogen on the right? Yes, the nitrogen here only got N, nothing else. So it's element. So when you are element, oxidation number, it is 0. So nitrogen from +1 to 0, oxidation number go down. Oxidation number go down is reduction process. So when you undergo reduction process, you are oxidizing agent, not reducing agent they want. So the answer B is wrong. So some people say, Mr. Martin, what about oxygen? Oxygen is -2 here. This oxygen also -2. So anything no change, don't bother. Okay. So the answer B is wrong. Okay. Answer C. Okay, sorry, before that, this question some people ask, Mr. Martin, if I don't want to use oxidation number method, can we use, okay, right? If we don't want to use oxidation number method, can we use oxygen method? Yes, you can see N2O on the left become N2. So if we use the oxygen method that we learned last week or last lesson, on the left, the nitrogen sticking with O. On the right, the nitrogen don't have O. So what happened? Lose oxygen. So when you lose oxygen, what process is happening? Reduction. So when you undergo reduction, you are oxidizing agent. Also can. So this question, if you want to use oxygen method, also can. No problem. Okay. So I get a question here in the chat box. Is the oxidation number for nitrogen is different in all compound, or it is always +1? It's always different one. Like the nitrogen in nitric acid, the nitrogen in NO2, the nitrogen in N2, the nitrogen in, let's say, ammonia, all are different. That's why when you have nitrogen, you don't know the oxidation number, you always need to calculate. You always need to calculate, right? That's why if you think back, the 4 rules that we learned don't have nitrogen, right? The 4 rules that we learned don't have nitrogen, okay? So that's why if you have nitrogen, you always need to do calculation to check what is the oxidation number. Haida, did I answer your question? Okay, you're asking what about K and Cl? K and Cl always fixed that. K is always K plus, isn't it? You never learn other charge, but you never learn K2 plus, K3 plus. So this one fixed already. Cl, you know, is Cl minus, right? You never see Cl2 minus, Cl plus, Cl4 minus, right? So all these things you know already. So if you know the charge of the substance, like for K or Cl, you know the charge already, then you don't need to calculate. But we don't know the charge for nitrogen, right? That's why we need to calculate the oxidation number for it. Okay, so that's the reason why we learn the calculation. Are you guys okay with this? Are you guys okay with this concept? Okay, good question, Haida. A very good one. Okay, at least when you ask, okay, everyone can learn from here. Okay, it's a very good question. Okay, let's look at answer C. Let's finish it up. Answer C. Okay, hydrochloric acid, the H is what? H plus, right? H plus is +1. The Cl is what? Cl minus, right? -1. So compare apple to apple. Okay, compare apple to apple. Hydrogen, compare with hydrogen. So the hydrogen on the right hand side here is element, right? 0. So on the left, hydrogen is +1, on the right is 0. +1 to 0, oxidation number go down, reduction process, oxidizing agent. So wrong. I want reducing agent. So the answer is donkey. The answer is donkey. Okay, so let me prove it to you. Give me 1 minute. Let me prove it to you to finish off with everything. Okay, let me prove it to you. So for answer donkey, if you want, you can use oxidation number method or hydrogen method also can. So let me use the quick one. Hydrogen method. On the left hand side, the nitrogen sticking with hydrogen. On the right hand side, the nitrogen come alone. So this nitrogen got hydrogen. This nitrogen don't have hydrogen. So what happened here? Lose hydrogen. So as what we learned in last lesson, lose hydrogen is what process? Lose hydrogen, oxidation process, isn't it? Look back to the table we learned. Okay, the table that we learned. Okay, so lose hydrogen. Okay, it's okay. Yeah, just a quick one here. Right, go back. Okay, here. Lose hydrogen, it's oxidation process. Okay, so it's oxidation process. So when you undergo oxidation process, you'll become the opposite agent, opposite reducing agent. So the answer is donkey. So if you don't want to use hydrogen method, if you don't want to use hydrogen method, okay, if you don't want to use the hydrogen method, you also can use oxidation number method. So oxidation number method, ammonia, we need to check the oxidation number for nitrogen, right? Because we don't know the charge for nitrogen. So the nitrogen we don't know, and hydrogen is +1. So we have 3 hydrogen times 3. So add together equal to the charge. No charge here, 0. So the nitrogen is -3. So this is -3. Hydrogen here +1. So let's look at the right hand side. So right hand side, the nitrogen, this one. How many is it? So N2, one species element. So element is 0. So -3 to 0. Oxidation number go up, right? -3 to 0. Number line, right? -3, 0. Oxidation number go up. So oxidation. So when you undergo oxidation, you are reducing agent. Okay, that's it. So that's why the answer is okay. That's why the answer here is A. The answer here is A. Okay, so that's it. Okay, that's it. All right. So that is how it works. Okay, that is how it works. Okay, all right. So not very, very hard. Okay, not very, very hard. Okay, so hopefully you all can get some rough idea. Okay, hopefully you all can get some rough idea on how it works. Okay, now let me see the question in the chat box. Okay, so the first question, okay, so Haida is asking why the first one is wrong again. So just now the first one we use oxidation number method. Oxygen here O2, O2 is element 0. The oxygen here is -2, right? 0 to -2, oxidation number go down, reduction. Reduction process is oxidizing agent, but we are looking for reducing agent. That's why answer A is wrong. Are you okay with this, Haida? Okay, Anna. All right. So one last question. Okay. Okay. So now, Jayani. So Jayani is asking, can the first question here, okay, can the first question here actually, we're using the oxygen method. Can we use the oxygen method for the first one? Okay, not advisable, not advisable. Okay, not advisable for the first one. Okay, because if you look at this question, okay, if you look at this question, okay, when you have a substance that got O3, it will have a lot of complication one. When you have something got O3, it will be very complicated. You will have a lot of complication when you use the oxygen method. So not advisable. That's why for me personally, like what I say, for me personally, I will always prefer and I will encourage you all to always stick with oxidation number method. That's the best method out there. All right. So I think that's it. Okay. So let's make a very quick conclusion what we learned today. Okay. All right. So again, a question. Duncan, oxidation number for PB can be +2 or +4. Yes. Okay. Most of the time the PB is +2 lah. But if you're not sure, just calculate long like this. PbO2. If you're not sure the PB is +2 or +4, just calculate lah. PB, then the oxygen is -2 times 2 equal to 0. PB is +4. If here the PB is PbCl2, PB don't know, the Cl here is -1 times 2 equal to 0. So PB is +2. So that's why if you have any oxidation number that you're not so sure, just calculate. Okay? Anything you're not so sure, just calculate. For example, like K, I know confirm K plus. Cl, I know Cl minus. Magnesium confirm Mg2 plus. Aluminium confirm Al3 plus. Now all these things I know. Like iron, maybe Fe2 plus, maybe Fe3 plus. I don't know. I need to calculate. Pb, maybe Pb2 plus or Pb plus. I don't know. I need to calculate. See? So anything you're not sure, you just calculate. Yeah? So Duncan, did I answer your question? Okay, good. All right. So I think that's all. So that's everything that we learned today. So, all right. So my last question for today. So how's everything, guys? You learn something? Are you guys okay and familiar with oxidation number method now? Okay. So it's not very complicated, isn't it? So remember a simple rules. If you know the charge of that substance, you use the 4 rules to do it. If there is any oxidation number you're not sure, or you don't know the charge of that substance, then you do the calculation to get the oxidation number. Okay, that's it. Then after that, you do your apple to apple comparison, and that's it. Okay, that's everything you need to know. Okay, so I think that's all for today. All right. So I'll see you in the next lesson. And next lesson, we will learn the last method, which is called electron method. So electron method will be much more interesting and much more technical, very, very technical. Okay. But no worry, that's something that we will learn in next lesson. So no rush. We will learn. Okay, we will take one step at one time. Okay. Do it slowly as long as you learn something. Okay. So I'll see you in the next lesson then.